In this video, we'll work an example of acceptance sampling. First, we'll see if the binomial probability distribution applies, and then we'll answer the question. A manufacturer receives batches of 1,000 components daily. The percentage of defects is known to be 2%. A batch is accepted if there is only one defect or if there are no defects. If 30 components are tested, find the probability that a batch will be accepted. So first, let's see if this is a binomial probability distribution. Is this a binomial distribution? I think that I got lost in there. Okay, so first thing we want to ask, are there a fixed number of trials? Yes, we're going to examine 30 components. N is 30. So that requirement is met. Next, let's see if there are outcomes in two categories. Well, we said we're going to look at them for defective or not defective, right, and in the inspection. So yes, and they are defective or not defective. Another way you could say this is, defect or I guess a reject or accept. But so they've used this term talking about defects. So I'll just say defective or not defective, but the same thing there. Okay. Number 3. Is the probability of success constant for each trial? It's a U. Yes, they told us it was the probability of a defect, that's going to be a success, finding a defect, is 2% or 0.02. Okay, and finally, are the trials independent? Well, if we were taking our 30 samples with replacement, we would immediately say yes. However, that's not how you would inspect a batch of components. You wouldn't keep putting them back in after you note whether it is defective or not. So we would not be doing this sampling with replacement. So then we have to ask ourselves, well, does it fit our rule that our sample size is less than or equal to 0.05 times the population size? So let's actually put the numbers in and see how that comes out. Alright, so we know our sample size is 30, and the population, well, how many they get that day? They get 1,000 in each batch. Okay, so is 30 less than or equal to 0.05 times 1,000? Well, 30 is less than 50. Yes, so independence may be assumed. Okay, we can make our cumbersome calculations less cumbersome because our sample is smaller than 5% of our population size. So in all, is this a binomial distribution? Yes, it is. Okay, that's great, because now our calculations will be easy to do. Alright, so the problem stated that batch is accepted, the batch accepted if 1 or 0 defects. Okay, so we want to find the probability of 1 or 0. Well, we could write that as the probability 1 or 0 is the same thing as saying that our x is less than or equal to 1. And recall that the, change colors here, the binomial CDF NPX is when we want the probability that our random variable x is less than or equal to some value, and that's exactly what we want. So that's what we can use. We can then use the binomial CDF N30 P 0.02 and x, that's this value here, 1. We want everything, cumulative means we want everything up to 1. We want that sum. Okay, so let's pull up our calculator and go to our distribution list. We want the cumulative distribution. There it is. Enter. Number of trials, 30. Enter. Probability this time is 0.02. Enter. And 1 is our x. Enter. Enter. NPX. This is the cumulative now. It's adding the probability of 0 and the probability of 1, and we get 0.87945. 0.87945, or to 3 decimal places, 0.879. Or we could say that there is an 87.9% chance that the batch will be accepted. We accept if we don't find any defects or 1. Well, the chance that that happens, 0 or 1, is 87.9% of the time. So 87.9% chance the batch will be accepted.